Hi, in this video, you will learn how to decide if a lattice is a strict sublattice of another one. So assume you're given those two lattices, which are spanned by the spans of the columns of those matrices, okay? And so you're trying to decide if the one on the left is a strict sublattice of the one on the right. So the first thing, of course, is you have to decide if it is a sublattice at all. Okay, so being a sublattice means that you can rewrite your vectors, your column vectors in this case, as a linear combination of the columns of the vector of the other lattice. So this you can do by solving linear systems or even eyeballing it. So I'm just going to show it for those two column vectors. So 9, 2, and 7, right? That is 7 times 1, 0, 1 plus 2 times 1, 1, 0. Okay? Likewise, I can show easily that minus 2, 3, and minus 5. This is minus 5 times 1, 0, 1 plus 3 times 1, 1, 0. All right? So at this point, what did I establish? I established that that first lattice generated by the columns of 9 minus 2, 2, 3, 7 minus 5 is a sublattice of the other lattice, but is it strict? Now, what you could do is simply solve a linear system showing that some vector of the lattice 1, 1, 0, 1, 1, 0 does not belong to the other lattice. Now, I want to show you one method that relies on the volume of the lattice. And the reason why I'm doing this is because the volume is going to play a role in other problems that we have to solve on lattices. Okay, so real quick, the volume of our lattice that is generated by the columns of the matrix A is the square roots of the determinant of A transpose times A. Okay. So I'm going to calculate the volume of those two lattices. Now, if they have the same dimension, then whoever has the larger volume is strictly included in the other one. Now, if they have the same volume, then I can conclude that these two lattices are in fact equal. Okay, so let's calculate the volume. For that, I'm just going to use Maple because I'm being a little lazy. So here is my one matrix here, and then I'm gonna define M2, right? Which is gonna be the other matrix. So what is it again? 1, 1, and then 0, 1, and then 1, 0. And then I'm going to close all these brackets. And then, all right. So now I can just simply calculate the square root of the determinant of both of these matrices. So determinant of transpose of M times M, all of that to the power 1/2. Okay. Oops, what did I do here? Oh, I forgot this. All right. And then, so what do I get? So square root of 2883, okay? And now if I do determinant, the square root of determinant of transpose of M2 times M2, right? And then I raise that to the power 1/2. Then what do I get? Oops. Apologies. I get square root 3. Okay, so what do I learn here? I learned that, since the lattice generated by the columns 9, 2, 7, minus 2, 3, minus 5, this we already knew it's including the other lattice. Now its volume strictly larger than the volume of the lattice where it's included, so that inclusion is strict, okay? Now, like I said, this would have been easy to prove also by solving linear systems, but I just wanted to, in this problem, to emphasize the role of the volume when deciding inclusion of lattices. Thank you very much for listening.